Okay, now we're going to start the second topic, which involves triangles in trigonometry. The first rule we learn is Pythagoras rule in exercise 1A. So exercise 1A1, question 1, part A, we have to solve using Pythagoras the length of the unknown side x. This is 1 metre, this is 1.2 metres. Pythagoras has to start off with the hypotenuse squared. So it's 1.2 squared has to equal the sum of the two sides squared individually. So it's x squared plus 1 squared. You have to start off with the hypotenuse because that's the biggest side. That's made up of the sum of the squares of the two smaller sides of the triangle. You have to have a 90 degree to be valid for Pythagoras. And now if we work this out, we'll be able to find x squared. Now to find x squared by itself, we need to get 1 squared over to the other side. And we do that by subtracting it, because at the moment it's adding. On the opposite side you use the opposite operation. So it's 1.2 squared take 1 squared. And if you do that on your calculator, 1.2 squared is 1.44. So 1.44 minus 1 squared is 1, is equal to 0.44. So that is what our x squared value is. Now we need to find x. To find x, opposite of square is square root. So we need to square root 0.44. Now we need to put plus or minus whenever you square root, because when you square a negative number you get a positive number. For example, if you had x squared equals 9, then x equals plus or minus root 9, which equals plus or minus 3. Now the square root of 0.44 is approximately 0.66. However, we're just going to go with the positive value because you can't have negative lengths. So you write a little note saying that can't have minus lengths. And so we only go with the positive value. So the length of that side is 0.66 metres. Now you could work out x in the following ones. They are a little bit easier because x is on the hypotenuse. You don't have to rearrange it like the one we did. All of these are very similar, except it's in context. This is a roof, and you have to find the unknown length of the slant height, or you use that triangle 4.2, and this is 9, and you have to work out AB. They're all similar. This one here is a golf shot. Once again, use Pythagoras, x being the distance from the tee to the flag. And you can get harder ones where it's three-dimensional, like this. If you had to work out the distance from A to D, you have to do 2 rules. First of all, if you look at the right-angled triangle from A to B and B to D, you can see that we've got AB is 3 metres, but we don't have BD. And BD can be worked out by BCD triangle, because we got 4, we got 6, and use Pythagoras we got x. So you see over here, first of all use BCD, Pythagoras you get x squared, and you get 52. Then you plug it into the second triangle, and you can get y being 7.81. So you have to use Pythagoras twice to get the AD value. And there are some three-dimensional problems there. That's really Year 10 revision. We're going to start with the Year 11 concepts with sine, cos and tan. So we're going to be using this unit circle, but first we'll start off with some notes. And the notes, we'll put the heading trigonometry. And trigonometry is going to use sine, cos and tan, and you should have learnt the rule SOH, CAR, TOA in previous years. That's sine equals opposite over hypotenuse, cos equals adjacent over hypotenuse, tan equals opposite over adjacent. Now what we're going to do is relate this to a unit circle. Now a unit circle is a circle that has a radius of 1. Unit means 1 in mass. So that's our radius. In our test, coming from the last section on functions, I was asking you to find 3 points on the outside of a wheel. You chose these points here because it was easy. But what we're going to learn in this topic is to find something in between at a random angle theta to the horizontal line. So we're trying to find this point corresponding to this spoke at that angle. Now the way we can actually get those coordinates there is by looking at sine and cos. First of all, let's write down cos. Cos theta equals adjacent over hypotenuse. Now to get the adjacent and hypotenuse we need a triangle, and the triangle will come from this triangle here. This is a right angle. Now you can see the x coordinate is actually the distance from here to here. This is the x coordinate. You go so many centimeters across the x axis, and then you go so many centimeters up on the y axis. So that is x and this is y, and this point is x comma y. We want to express x and y in terms of theta. Now cos theta equals adjacent over hypotenuse, a over h. Now adjacent using this triangle is x. The hypotenuse, because this is a unit circle, the hypotenuse is 1, so it's x over 1. So we have cos theta equals x over 1. Anything divided by 1 is itself. So we've got cos theta equals x. So we can now rewrite this. Instead of being x comma y, we can have cos theta comma, and now we'll work out what the y is. To work out the y, we use sine theta. Sine theta equals opposite over hypotenuse. Now the opposite of this triangle, opposite the angle, is y. So it's y over hypotenuse is 1. So sine theta equals y on 1. So sine theta equals y. So now we can come back and add that into here. And so now we know there's 2 ways of saying the coordinate, xy or cos theta sine theta. Right, so you just have to commit that to memory, that the cos value is associated with the x value, the sine value is associated with the y value. Now as an example, we'll do it for 30 degrees. So when theta equals 30 degrees, what's the coordinate going to be? Well, this point sitting on the edge of the circle for 30 degrees, that point there, the coordinate of that point is going to be cos 30 comma sine 30. Now to get that in the calculator, you just punch that in. So if we do cos 30, enter, then it's 0.15. However, that's incorrect because you've got to be really careful that to be in degree mode. So if you click the mode in the calculator, you've got to go down and change the radian to the degree. Now go second quit, and this time we do it again, cos 30, enter, so it's 0.866. That's the correct answer. So come back in here and put 0.866, and now we've got to follow it up with sine 30. So if we do sine 30 equals, it's a half. So it's 0.866 followed by a half. That's the coordinate of that spoked 30-degree spoked point on a unit circle. Now let's actually compare that with the book. If we go to the textbook, you can see the 30-degree line is this line here. That's the spoke going out to the edge of the circle at 30 degrees. Now the coordinate of that point we found with the calculator is 0.866, 0.5. And if you look at this here, there is our triangle, and we can see the x-coordinate is sitting here at 0.866, because that's 0.5, 0.6, 0.7, 0.8, it's about 0.86. The y-coordinate is sitting up here on the y-axis at 0.5. So that agrees with this graph with half of the unit circle. Now if we look at the next set of questions from the textbook, using that rule that we've learnt, we should be able to do that fairly quickly. Use the unit circle above to find cos of 0. Now cos of 0, cos is the x, and cos for the 0-degree line, you can see this is the point, which is 1, 0. The cos value is the x-coordinate value, so we say cos 0 equals 1. Cos of 0 equals 1. Now the sine value is the y-coordinate value. Sine of 0 degrees is equal to 0, because the y-coordinate of that point is 0. That's this one here. Right, so cos of 0 degrees is 1, sine of 0 degrees is 0. Okay, so you can try the next set of questions. So we've done cos 0 and sine 0. You try C, D, E and F. So you can pause that now and try that and come back for the answers. And here are the answers for 1B1, question 1, A, B, C, D, E and F. Okay, now we'll do question 2 and 3 together, because 3 is just check your answer to 2 using your calculator. So I'll do the first one, cos 70, and you can try the rest. So cos 70, we've got to find the 70 degrees, and that's this line here. And if we want cos of 70, we want the x-coordinate of 70. Now the x-coordinate is the coordinate on the x-axis corresponding to the point on the edge of the circle, and it looks like it's 0.1, 2, 3, about 0.35. So we can say that cos of 70 equals 0.35. Of course, if we wanted sine 70, we're actually reading this value of here, and that looks about 0.95. So I think that's part B. Sine 70 is 0.95. Now just to check in the calculator, we can do cos of 70 and we get 0.34, and sine of 70 and we get 0.94, so pretty close. So this is actually determined that this coordinate here, that coordinate, the coordinate of that point is 0.35, 0.95, or the calculator 0.94. And that's how you do those questions. Now have a look at 2. We've just done A and B, so you pause the video and try C, D, E, F and come back for the solutions. And here are the solutions for 2, A, B, C, D, E and F.